Hello, everyone. Hey, Phil.
Hi, how are you doing?
Very good. Welcome to another exciting webinar from Preview 3D. We have a lot of exciting stuff to show you today. And as always, feel free to write some comments. We'll be more than happy to answer any questions you have. So we've been working pretty hard over the past several months, and a lot of it is coming to fruition into the product. And we just came back from a trade show, Intergeo in Germany last week, and that was a really a good sign of the excitement and the interest on all the latest stuff we've done. I think we could start. Basically, I guess you'll need to share your screen, Phil.
Yeah, sure.
A lot of the focus we've done with this release 24.9 is really about engineering workflows. You'll see a lot of things that many of our customers and potential customers have asked us for the past while, and we made a big push on really improving the capabilities of our solution. So as always, you can see that our quality of our meshes always stays the same. We've made some slight improvements here, but definitely a key milestone of what we're doing. One of the first feature I think we're going to show is that we've been often asked about, hey, I have my CAD model, but I don't know if it's up to date to the as-built environment that I see into your scan environment. And so we've built this really simple tool to allow you to visually compare your CAD models to the environment. And it's really useful because it's a tool that enables all the existing tools in the platform to work. It just creates a visual layer that allows you to compare. So here, Phil just enabled it. So you can see now with this default color spectrum display, you can see what's green is the most closest to the actual model. You can, of course, adjust the threshold. And of course, like things like grids, of course, we'll see more coloring in there because the CAD model is not as precise as the actual scan. But you can see very quickly, what's colored is where there's models, but some differences. Here we can see that some of the dots are not modeled exactly the same. And of course, like moving objects like the ladder and the beam structure and other things are not into the CAD model. So therefore, they're not colored at all, right? So it's really simple tool, but very efficient to help to draw, to see the differences. And then you can use like our annotation tools to annotate any comments. Let's say you want to mark that this beam should have been modeled into the design, then you can just say, I'm going to create a note and basically publish that online, and then you can have your colleagues access this annotation on things you need to change on your design. So that's already one really nice feature that we've done that helps our customers that are doing engineering work and making sure that their CAD model is up to date with the as-built conditions.
Yeah, and it's a great way. Over here, there's two main use cases. You can see the deviations, but also what is missing, like Michel mentioned. So you can really see the deviations between the two models. You can set the threshold over here. You can decide if you want to apply like a linear difference like this or flat. So if it's above the threshold, it will be marked as red. If it's between the threshold, it will remain green. So you can quickly assess what is good or not in your models. And if there's no color, there's no 3D model, so
Yeah.
it's easy to spot.
You can also
Any
switch
missing.
the sources. Like if you flip between the two, now you're going to see everything in red is really showing what's not in the CAD model. So all the floating objects, the trash cans, and everything else. So there's two ways of visualizing the information. I personally prefer to compare the 3D to the environment because the reddish, gets on some of my nerves personally, but it's all a question of like preferences. But it's definitely quite useful as a first tool that we've done. I don't know if anybody online has any questions about this, but that's definitely one cool thing we just added into the platform. And you've seen from the performance perspective, this does not impact the navigation performance of our fluid user interface to navigate across the environment. It's really a nifty trick that we've done to make this a seamless visual integration of comparing dynamically the environment with the CAD.
And over here we can see the actual CAD model that is behind the mesh, so you can like visualize them if you would like, and you can enable at any time the comparison tool if you want.
Yeah, exactly. Cool. That's one first thing. So I already one good one. I think the next one. So we used to have this clash detection, but it was more of like an on-off type of clash detection. We would display red or green of, okay, this object clashes, but you couldn't really tell where the clash was happening. And so it was a really nice, simple first implementation of a clash detection, but we felt that we wanted to do better. And so we reworked completely the clash detection system. And now what we're going to show you is actually a solution that is still very much interactive, and you can have precision on what you're clashing against, right? So it's really useful. For example, if you have some specific CAD designs and you want to see if there's any clashes with your new piping design that you brought into your as-built environment, to use this now to have clash detection. And one of the really key thing is that, there's other solutions out there for clash detection, but a lot of them, especially with bigger environments, are pretty much very long to process. Here we're going to talk and see clash detection in seconds, and for very, very big tests we've done, like a minute, like very, very fast, like not hours. Like we know that there's other solutions out there that can be all the way to hours in doing the same thing. So really key to see that difference.
Yeah, so I can maybe show you like a quick example first with a cube, and I can go through a more advanced workflow to show you exactly how it can be used. So just from start, let's start with a simple cube. We can now right-click on the object and enable the Evaluate Clash tool over here, and you can decide against what it should be evaluated. So we can specify the environment, and as you can see, if the cube is touching nothing, it will be marked as green. But now if we touch something like this conveyor, you will see all the collision points that are highlighted in red like this. So it's super good visually to know exactly where it hit. Obviously, for a small cube like this, it's not super relevant. But let's say we were to introduce like a new equipment over here. What we could do is use the cutting tool, remove the hold machine like this, and from there you can quickly get rid of old equipments. I won't even give it a name. I will just clean that out like this. Yeah, actually it was.
Again, like it's good to show at the same time that we still have these capabilities of cutting assets and move them around and everything. So
yeah, so we can easily edit the 3D model that we have over here. As you can see now, it's progressing. It's deleting the machine over here. And what we can do in the meantime is we do have a 3D library where we can import any CAD files. So if you have models from SolidWorks, Inventor, CATIA, or any CAD software mostly, we can support those files. So we can import them as NWD, step files, or a lot of formats are supported. So over here, for the example, I do have like a machine that was imported. So I can place it in the scene. And let's say that's the actual position I would like. I can now evaluate the clash for that object against the environment. As you can see, it will take a few seconds to compute the collisions because this model is a bit bigger than the cube.
yeah, it's very quick.
But now you can quickly see that we are touching over here the guard. So it's easy, and you can see like all the collision points with the existing machine over here and the palette there. So you can quickly access what is touching or not.
Yeah, right now, if some of you may be asking the question, this is a hard clash calculation. We are going to be adding soon soft clashes, and as well another asked question from some of our early testers has been that we generate reporting. So that's on the works. It's going to come in a future release of the product very soon. But already you can see this is a major improvement in the clash detection from the previous version, where before we just had seen red or green, but we didn't know where the clashes are happening. So here you see a good example where the staircase it's obvious where there's a collision between the new equipment and the staircase, and therefore you want to be able to either change your CAD design or move it a bit to remove that clash aspect. But it's definitely quite another useful tool that we've added into the application.
Yeah, and it also works against other 3D models. So if you have like a cube, and other equipment, you can compare those two equipments to each other's, or with the environment. So it's really easy to assess if there's any clash. The obviously, like if you have very large model, that's where you have like a lot of benefits, because sometimes it's hard for you to, like with the previous tools that we had, it was like contact or not. For small equipment, it was easy to see and where it was clashing, but when you have like large scale model like this one, you can clearly see where it is.
Yeah, absolutely. So we have more stuff to show. The next one has been like, we already have a lot of like measurement tools that can measure like length and areas and other things. We also had this unique diameter calculation, but we didn't have any ways of measuring a volume. And so we added into the solution now the ability to measure volumes. So we can definitely show that as well. I think for a lot of people are doing these kind of like brownfield expansions or greenfield projects, and you want to measure your landfill or your stockpile or other sources of material that you want to measure. Definitely, this volume tool is going to be quite useful for this.
So yeah, the tool how it works is you define like your first plane. So let's say over here we established a plane like this, then you close the loop, similar to the surface measurement tool. And once it's done, you will end up having your cuts and the fill and the net value of your volume. So the cuts represent everything above the plane that was defined, which is the middle one. So you can see everything above the plane, and the fill is the gap that will be filled. So it's everything below the plane. So let's say we increase the middle plane over here at the middle of this wall. You can see like how many square meter you would require to fill the gap over here to be at the same level than your plane. So it's really a quick way to assess to measure volume.
Yeah, absolutely. And all you guys in online, like, feel free to ask any questions. We always like to answer any live questions you might have. I think the other thing we wanted to show is, sometimes, it's good to be in a 3D environment, but sometimes some people don't necessarily have a performant machine, or they just want to look at the imagery of the scan. So we've improved our Photosphere navigation. That's definitely something that we're getting a lot of requests from people that are looking more for doing like tours of a facility using this reality capture data. And so
So let's say now we with the asset creation tool, you can define assets in the scene. So let's say I define this machine over here quickly. Let's say and we do have like a small turntable at the bottom over here, so you can easily rotate around the equipment and adjust the size of the box if you would like this. And once it's done, you can create an asset out of it. And those assets can be visualized through the photospheres. So you can select them and visualize their properties that they may have. So you can even attach new properties to those assets. So let's say
almost feels like you're in a 3D environment, but you're actually looking at an image, right? But all the assets are selectable even to this mode now. So that's really powerful for users that want to access the information that's been attached to assets without having the 3D capabilities necessarily. So you're just moving into the Photosphere mode, click on assets, see any information. So very powerful for accessing any information. I know that some of our customers are attaching health and safety documentation, for example, other information. So that makes it extremely accessible, even for the laptops or computers that don't have any decent graphics card. You can use this as a Photosphere mode, and it's very flexible for that.
Yeah, and even for non-technical users or the one that are less familiar with navigations, I think Photospheres is always easy. People are used to Google Map and all those type of navigations, so it's pretty similar. You click, it goes to the closest picture, and you can quickly visualize the information. And like even the 3D model show up inside the picture, so everything you had will be shown.
Yeah, cool. The next thing we want to show, you see, there's a lot of things we're showing you this today. The next one is we've been, looking at how we can improve the workflow for designers and engineers between what we have, the data that we have in Preview 3D, and the work you have to do in your various engineering tools like your CAD system or your BIM software. And so we looked at, obviously, we can do file export, like you can export a, RCS file for a point cloud or export a GLB file, for example, for a 3D model, but it's a bit cumbersome, right? So what we're doing now is we're actually building native plugins for different software. So the one that Phil was going to first show is our integration with Revit. And so that is something that is now shipping. So if you want to try our Revit integration, you can definitely contact us at sales, and we're more than happy to give you access and try how you can bring different elements from point clouds in various densities or meshes, and also these reality assets. You'll see a lot more of these integrations where reality assets are becoming a core component of all of our workflows, where you can click and select these assets, attach documents to those, and also bring those assets, for example, into your Revit family, which is something that is quite useful if you want to do some back modeling or eliminate some back modeling if you're trying to reuse some assets as a context for your specific design project.
Yeah, so from RealityPlan now, you will be able to enable the RealityConnect for Revit over here. So you can enable the connector. Once it's done, you will be able to go on your Revit, and obviously you will need to install the plugin. But once it's done, you will now have the Preview 3D tab that shows up at the top over here, and you can basically sync your scan. So from the sync scan feature, you can either sync the point cloud or the mesh. So it's up to you which one you prefer. So you can proceed like this. So the sync scan will bring a low resolution version of your full space. So afterward, you will be able to use the clip scan to load higher resolution in some specific area. So this way you only bring what you need to proceed to your modeling. So as you can see quickly, we do have like a rough overview of the site. It's not super precise at the moment, but you can proceed with clip scan features to increase some accuracy. So what I will do, I will go under the default 3D view, and I will create a section box inside Revit. And from there, I can select the area that I would like to load at a higher resolution. So let's say we pick this corner, because we need to do modeling around the piping or something like that. I can go and clip the scan and pick a different resolution. So let's say we pick 7 over here. It will start to load that specific area. So depending on the resolution that you pick, the size of the box that you select, the time that it takes may change a little bit. Obviously, we load more data over here because the resolution is a bit higher, so it might take a few seconds, but you will see the difference. In the meantime, if there's any questions, don't hesitate to ask in the chat. We will be more than happy to answer them. It can be related to the previous tools as well that we have showcased.
Yeah, absolutely. What's great with this implementation of multiple densities of point clouds and meshes, it gives the engineers or designers a lot of control in really getting all the data you want, depending on what you're trying to do. So here you have a very dense point cloud that we've generated, and so that it can be quite useful for creating your space. And you can disable that. So you can see now we have low res and higher res densities of point clouds into the same environment. So a lot of control. So it's really powerful, easy to access, and you don't have to mess around with file export, import, and all of that. The plugin talks directly between the two products, and it makes it very seamless to work your engineering workflow.
And one other feature that we have is, like Michelle mentioned, is the loading assets. So we can quickly go in RealityPlan, define, let's say, a tank over here. Oops. We will use the asset definition tool. I will define this tank like this. And again, we can fine tune the position of the box. We have the small turntable at the bottom to help rotate around the selection. Once it's done, we can generate the asset, giving it a name. Let's say tank, like this. Now, if I go back inside Revit, you will see that I can press load asset and it will show me all the reality assets that I have within my scene. So I can now load the tank and pick again a quality level for that specific tank. So the tank should appear roughly up there because it was everything is georeference. Yeah, here we go.
And Phil's using an older version of the plugin, and the newer version has the ability to map the assets into the Revit families. And so that's definitely something that we've added recently. We had a small.
Revit is requesting me to do some saves. But yeah, there we go. We do have like the models over here. You can enable or disable the texture if you would like. So it's up to you. If I put realistic, basically when I move around, it will remove the wireframe, so it look even better. But yeah, and it's part of the generic asset at the moment. But eventually, well, with the new version that we have, I just don't have it installed on my computer at the moment. But you will be able to pick the category of the family.
Yeah. And so, of course, Revit was the first one we did. And I don't know if you've seen some of our LinkedIn posts recently, but we have a few others in the works that are basically now entering this beta stage. And so Phil has a few videos to show you additional of these RealityConnect plugins. I think the next one we'll show is going to be Inventor, I think, right, Phil?
Yeah, we can proceed.
So let's show a bit of Inventor. It's good to see that, yeah, we'll have a similar integration where we can load up variable density of point clouds and meshes and reality asset right inside of Inventor. So similar workflow. Here the video shows how to load a higher res version of that specific part. So again, making it very seamless for different CAD systems to integrate point cloud, meshes, and assets. And so that's what we're doing with Inventor. And of course, when we were showing this on LinkedIn, when we're showing Revit and Inventor, then the next question was like, well, what about AutoCAD? And so specifically, we've been working on an integration with AutoCAD for Plant 3D, which is often used by manufacturing companies. And so we'll show you that as the next video right after this one. Here we're showing again how to load reality assets into the space, same mechanism that you saw with Revit. So very flexible, very easy to enable your different workflows, no matter what type of 3D software you're using. There you go. So you have this as an asset, and you can then use it to remodel the surface of that, or just use that as a reference into your facility when you design a new part to that equipment. And then you can use Inventor to model that extra extension to that asset. Let's move to AutoCAD Plant 3D. Yeah.
Plant 3D over here.
AutoCAD Plant 3D is slightly different because this notion of clipping area doesn't really exist in AutoCAD. So you can, in Preview 3D RealityPlan, you can define clipping areas. So you have to predefine your clipping areas in the context of AutoCAD, but still same kind of integration where you're able to bring your point clouds and clip things and bring reality assets right inside of AutoCAD. So again, completing that threesome of key products from Autodesk with these integration. And of course, then the next
I can maybe
question
show over here the clipping box. So basically, like Michel mentioned, from Preview 3D, we do have the clipping box feature. So you can easily create a clip like this, select the area that you would like to visualize, and that's the clip that you will be able to load within Plant 3D.
And the next one we did was actually SolidWorks. And so we didn't want to just do Autodesk products. So the next one is the one we're doing for SolidWorks. And this one is definitely pretty exciting because there's a lot of SolidWorks users. I see that one of the questions we have on the chat is like, do you have any plans for CATIA? And so, yes, definitely we're looking to add also CATIA. SolidWorks was the first of the Dassault products we want to integrate in this workflow. We don't have any information yet on when that will be available, but please contact our sales team if you want to know more about CATIA availability. But at least you've seen the one for SolidWorks, and so we're doing more of these integrations. And so that was around RealityConnect. There's going to be more connectors being announced in the coming months, so lots of good surprises. And actually, we have one more thing to show. And so often customers have been asking us, okay, well, great, you love your meshes, but your meshes is for a single device at a time. And a lot of our customers have multiple scans they'd like to use into our meshed environment. So we had been asked for a long time about how can you make that possible to combine multiple scans from different sources, drone and terrestrial and SLAM, or use different scanning sessions. Let's say you've scanned maybe a whole facility and there's a whole section that has been rescanned. And so we are going to show you something, actually something called space composition that's in the works. It's not available just yet for customers, but it's coming soon. But this tool will basically allow us to combine multiple scans. And what you'll see is actually a prototype, an internal tool we built to make that happen. What's unique is that there's a lot of tools that integrate or combines multiple point clouds together. And in some ways, it's a somewhat much simpler process to combine points and images in space. But combining multiple scans at the mesh level in a continuous and coherent environment is quite difficult. Here you're seeing all the blue is basically drone data, the yellow is a Navis VLX, and what was in purple was actually terrestrial scanner on the same space. And so we're creating this tool where you can actually create bounding areas and really construct a volumetric environment of a combination of multiple scans. And so space composition is going to be definitely another of these key changes into our product offering very soon. We're able to say, I want to use a drone for most of my outside of my facility, terrestrial for the bulk of my large space, and then maybe there's some specific rooms or areas that you need the precision of a terrestrial scanner. And ultimately combine all of that very easily. Here you see here in this prototype how we able to just move points of a bounding box to change what's being used between the drone and the terrestrial or the Navis scan. And so that's coming very soon. I would say it's coming sooner than you might think, but that's another really cool feature that we're adding into our capabilities. I don't think I've ever seen another software capable of merging multiple meshes together. Definitely, if you know I've seen that before, I would love to hear about it, but I think this is unique. And that's also, as you can see, this is very performant. This is not impacting performance of our viewer. It basically makes it an ability to create more complex spaces. And so when we're going towards more of these operational digital twins and enabling the composition of a twin with multiple scans, if you make a repair and you rescan some machinery, you want to update your digital twin, space composition will be also a fundamental key element to enable the maintainability of a visual digital twin for maintenance and operations use cases.
Yeah, I think that's a good point. Updating the space is something that has been requested by some customers. I think they will be pretty happy to see that.
Cool. I don't know if there's any questions on our side. We have covered all the material. I think that there's a question coming in. One of our yes, that one we've answered before. So yes, CATIA, we are looking at it. We've done SolidWorks. We answered that before. So SolidWorks is the first product from the Dassault family. but definitely we are looking at the CATIA. We don't have any information of when that would be available, but definitely this is something that we'll be adding as well to our future plans. And so on that note, well, I want to thank everyone that has listened to this webinar live. It was recorded, so we'll share the recording for offline viewing. Any questions you have, any projects where you want to use some of these tools that we'll show you today, if you have any specific engineering projects that you'd like to use our visual compare or clash detection and other of these capabilities, please contact us. We're more than happy to work with you. We often do pilot projects, or we're more than happy to work on an active engineering project if you have them. And so, Phil, thanks again for all your craftsmanship in showing the product capabilities. And thank you, everyone.
Thank you. Have a great day.
Good day.